The Luftwaffe was destroying British fighters faster than Britain should have been able to replace them. German pilots reported victories, airfields received bombs, and damaged machines vanished from operational squadrons. Yet aircraft believed removed from the battle kept returning beneath different pilots. To German intelligence, Fighter Command appeared to possess an impossible reserve. How could a wrecked fighter disappear from an airfield and re-enter the war? The answer was not a miraculous aircraft factory. It was a recovery and repair system extending far beyond Fighter Command's visible bases. Its raw material included machines that ordinary accounting might have treated as permanent losses. A Hurricane with a damaged wing could look finished beside a cratered runway. A Spitfire forced onto its belly might appear even less promising. But appearance did not determine whether Britain had lost an aircraft. The decisive question was who inspected it, which components remained usable, and where the airframe went next. That distinction mattered because both sides were trying to measure an attritional battle in real time. Pilots saw opponents fall, smoke, or descend through cloud. Commands converted those observations into claims, estimates, and predictions about the enemy's remaining strength. Those predictions shaped the next raid. They also shaped the expectation that one more concentrated blow might finally empty Britain's fighter stations. Germany entered the campaign with reasons for confidence. The Luftwaffe had helped overwhelm Poland and defeat the Western Allies on the continent. Its units possessed combat experience, mobile support organizations, and commanders accustomed to rapid operational victories. Britain had lost aircraft and equipment during the fighting in France. Its fighter pilots now faced repeated raids while southern airfields operated under direct attack. The strain was genuine. There was no bottomless reservoir of trained pilots, mechanics, spare parts, or undamaged runways. However, the Germans were not striking an air force whose strength equaled only the fighters visible on squadron dispersals. Behind those dispersals stood maintenance units, storage organizations, manufacturers, civilian workshops, salvage teams, and transport links. Together, they changed what the word lost meant. This system had not appeared fully formed in the summer crisis. Before the war, the Air Ministry already understood that a major conflict would create repairs beyond ordinary service capacity. Lord Nuffield's industrial organization helped develop what became the Civilian Repair Organization. Motor manufacturers and other civilian firms were drawn into aircraft recovery. Component repair, overhaul, and reconstruction. The arrangement initially suffered delays, and a growing accumulation of machines awaiting attention. War exposed every weak junction. Responsibility changed, procedures evolved, and the repair network was pushed to move faster. When Lord Beaverbrook became Minister of Aircraft Production, aircraft repair came under the same urgent pressure as new construction. A damaged fighter now entered a sorting process. Ground crews handled defects that could be corrected locally. More serious cases moved to maintenance units or civilian repair facilities. Airframes beyond economical restoration could still surrender engines, instruments, radios, guns, undercarriage parts, and usable structural sections. One wreck could therefore shorten the absence of several other aircraft. That was the first hidden mechanism. The British fighter force regenerated through both production and recovery. Factories added new machines, but workshops prevented repairable ones from becoming permanent deductions. Cannibalization prevented completely ruined aircraft from becoming completely useless. Standardized types, organized inspection, specialist labor, and transport connected those decisions. The mechanism ran from cratered grass to technical assessment. From assessment, the aircraft or its components moved through military and civilian repair channels. Workers restored what could be saved. Serviceable machines then returned to storage pools and operational units. The effect appeared over the same skies where German analysts thought the defending force was approaching exhaustion. This did not make British losses imaginary. Aircraft were destroyed, pilots were killed, and squadrons were stretched close to their limits. Repair could not replace an experienced airman, nor could every twisted fuselage be restored. But German estimates repeatedly treated an uncertain battlefield claim as a cleaner subtraction than war permitted. The repair network made that error compound. Each fighter wrongly counted as destroyed distorted the estimated total. Each repairable aircraft classified mentally as a wreck widened the gap again. Each new fighter delivered from British production widened it further. By late August, German intelligence could describe Fighter Command as nearing its final reserve. The actual force remained several times larger than some German estimates suggested. This was more than an arithmetic mistake. It meant the Luftwaffe was planning its next blow against an air force that existed differently on paper than in reality, and behind that difference stood a battered fighter waiting beside a runway. Not yet dead, merely entering the system. The journey began with men who could distinguish destruction from damage under pressure. A fighter might have buckled propeller blades, torn skin, a collapsed undercarriage, or bullet holes across one wing. Some failures looked dramatic while leaving the engine and central structure recoverable. Others appeared modest but concealed distortion that made an airframe unsafe. Ground crews performed the first triage. If repairs could be completed on the station, mechanics worked among dispersal pens, blast damage, and interrupted power supplies. Speed mattered because every serviceable fighter affected the next day's available strength, but speed without judgment could return a dangerous machine to flight. Aircraft requiring deeper work entered a wider chain. Recovery crews lifted damaged airframes from fields where they had landed or crashed. They removed wings when necessary and loaded the remains onto transport vehicles. The machine then traveled away from the battle's most visible geography. This movement created the illusion of disappearance. To an observer, the fighter had left its squadron and ceased to exist. Inside the repair system, it had merely changed custodians. Its squadron cared about tonight, serviceability figure. The repair organization cared about whether it could fly again next week. At workshops, civilian and military specialists divided complex damage into manageable industrial tasks. An engine could be removed and sent through its own overhaul stream. Instruments and radios followed other routes. Airframe sections were repaired, replaced, or reclaimed according to condition. The fighter was no longer treated as one indivisible object. It became a collection of recoverable functions. That principle allowed the system to extract value even when complete restoration made no sense. A written-off aircraft could donate scarce equipment to another waiting machine. A repair delayed by one missing component might be completed from salvage. The result was not elegant. Reconstructed aircraft could carry panels and major assemblies drawn from different donors. What mattered was that inspection certified the finished machine for service. Civilian participation expanded the available labor and factory space behind this process. Britain's motor industry possessed machine tools, production knowledge, skilled workers, and experience organizing complicated flows of components. These firms did not replace the RAF's maintenance establishment. They enlarged the territory through which damaged aircraft could move. The battlefield's rear boundary now reached into ordinary industrial Britain, yet this network was vulnerable. Transport delays could trap airframes between collection points and workshops. Incomplete records could separate components from the machines needing them. Bombing threatened factories, railways, depots, and electricity supplies. A shortage in one specialist part could immobilize an otherwise completed fighter. The repair system succeeded through persistent coordination, not frictionless efficiency. This distinction is important because Fighter Command's survival is often reduced to new aircraft production alone. Production was essential and increasingly powerful, but monthly factory totals did not reveal how many damaged machines avoided permanent loss. Nor did they show how repaired aircraft. Reserve stocks and newly built fighters entered operational units together. German intelligence had to estimate the combined outcome from across the channel. Its analysts faced incomplete reconnaissance, inflated combat claims, and mistaken assumptions about British industrial capacity. They also failed to account adequately for the machinery of repair and maintenance. Their model concentrated on visible destruction. Britain's system concentrated on reversing as much destruction as possible. The difference accumulated sortie after sortie. Suppose a German pilot saw a British fighter descend trailing smoke. The claim might be honestly made, but the aircraft could land inside Britain while its pilot survived and its structure remained repairable. German paperwork could record a victory. British paperwork could record damage, recovery, inspection, and eventual return. Both records described a real event. Only one captured the aircraft's final fate. Geography strengthened the British advantage. RAF pilots often came down over friendly territory. Surviving airmen could return to their squadrons while recovery teams reached their aircraft. German crews who descended over Britain faced death or captivity, and their machines became unavailable to Germany. The same aerial encounter therefore produced unequal possibilities after landing. Britain did not merely fight above its own repair network. It fought directly over its supply of recoverable machines and returning pilots. Every raid was followed by another contest conducted with cranes, trailers, spanners, inspection forms, and telephone calls. The Luftwaffe could see the first contest. It struggled to measure the second. By August, the difference between estimated destruction and surviving strength had become operationally dangerous. German air intelligence tried to calculate Fighter Command's decline from known strength, assumed production, and reported victories. Each uncertain figure leaned in the same optimistic direction. British production was underestimated. Replacement capacity was misunderstood. Combat claims removed aircraft that sometimes still existed. The resulting picture suggested a defender approaching collapse. Before the main offensive, Luftwaffe planners expected concentrated attacks to eliminate Fighter Command in southern England quickly. The remaining RAF would then be destroyed while German bombers struck its industry and supporting infrastructure. This expectation made sense only if British strength behaved like a shrinking inventory. Every claimed victory had to remain a permanent subtraction. Every damaged factory or airfield had to reduce regeneration. Every successive raid had to encounter fewer fighters. Initially, events seemed to support that logic. British squadrons suffered heavily while protecting convoys and responding to attacks across southern England. Pilots flew repeatedly, sometimes with little rest. Airfields received bombs that damaged buildings, communications, workshops, and runways. Aircraft awaiting repair could be destroyed before mechanics returned them to service. The system was under severe pressure, but the pressure did not produce the clean downward curve German planners expected. Damaged runways were patched. Communications were restored through improvised alternatives. Squadrons shifted between stations. Replacement fighters arrived from storage, factories, maintenance units, and repair facilities. The number available changed daily, but Fighter Command remained capable of mounting substantial opposition. German analysts had difficulty accepting what repeated interceptions implied. If their victory claims were broadly correct, the RAF should have been running out of fighters. When British formations appeared again, analysts could question the production estimate, the starting strength, or the claims. Too often, they questioned none of them enough. The system encouraged confirmation. Pilots reported victories under conditions where observing the final result was often impossible. Several attackers might claim the same falling fighter. Smoke, cloud, evasive dives, and combat confusion complicated identification. These problems affected every air force. Their strategic impact depended on how commands used the resulting numbers. Britain also overclaimed German losses. But British planning generally prepared for a prolonged struggle against a formidable opponent. German planning sought evidence that a decisive threshold was near. Optimistic errors, therefore, reinforced the preferred conclusion. The Luftwaffe responded by escalating attacks on Fighter Command's structure. Radar stations, coastal airfields, and later the sector stations controlling interceptions became targets. This was a rational attempt to break the mechanism directing British fighters. Bombing could disrupt operations even when it did not destroy many aircraft. Damaged telephone lines or control rooms might matter more than another crater in open ground. Yet identifying the system as critical nodes was difficult. German intelligence did not possess a sufficiently accurate map of how radar reports, observer information, group headquarters, and sector controls worked together. Some radar towers looked conspicuous but proved difficult to disable permanently. Their exposed steel structures could survive blast effects that damaged nearby buildings and cables. Repairs and temporary workarounds returned several stations to operation. Airfields posed another problem. A photographed crater did not equal a closed station. Grass surfaces offered room to operate around damage. Personnel could disperse. Essential functions could be restored before German reconnaissance confirmed what had happened. Bombing still killed ground personnel and imposed exhausting repair work. The resilience was neither automatic nor costless. It rested on people remaining at exposed stations and rebuilding functions faster than attacks could suppress them. The same logic governed damaged fighters. A raid might create 10 separate technical problems rather than 10 permanent losses. If the repair network resolved 6 of them, German planners experienced only 4 lasting reductions. If production and reserve deliveries replaced those 4, the defending force might appear unchanged. The arithmetic of destruction had collided with the arithmetic of regeneration. This collision became unmistakable during the major attacks of August. German formations repeatedly met British fighters after intelligence assessments had already reduced fighter command toward dangerously low levels. The continued resistance was interpreted as the final expenditure of a nearly defeated force. That belief made every new battle look like the last necessary battle. It also concealed the possibility that the underlying calculation was wrong. By the 3rd week of August, one German assessment placed British fighter strength at a fraction of its actual operational level. The precise daily totals varied with definitions and serviceability. The scale of the error did not. Germany was no longer merely uncertain about Britain's reserves. It was conducting an attritional campaign against an imaginary version of the RAF. The error became most revealing when German commanders tried to explain why the promised collapse had not arrived. One possibility was that Fighter Command possessed more aircraft than intelligence had originally estimated. Another was that British factories were replacing losses faster than expected. A third was that reported victories exceeded permanent British losses. Repair connected all 3 problems. It enlarged the reserve without appearing in new production totals. It returned aircraft previously deducted through optimistic claims. It also made British industrial strength harder to interpret from factory estimates alone. A fighter delivered to a squadron might be newly built, repaired, or transferred from storage. From the German side of the channel, the distinction was almost invisible. What mattered operationally was that another armed aircraft had appeared. This regeneration placed the 2 air forces inside different recovery environments. A damaged German fighter faced a long flight back across the channel. Fuel, engine temperature, structural damage, and the pilot's condition could turn a survivable hit into a total loss. A forced landing in southern England delivered both aircraft and pilot to the enemy. Even a ditching near the coast could end in death or captivity. A damaged British fighter needed only to reach friendly ground. Its pilot might land at another station or put the aircraft into a field. Recovery teams could then begin their work. The British advantage was not a superior airframe immune to damage. It was the greater probability that damage stopped short of permanent disappearance. That probability altered the cost of every exchange. 2 fighters could suffer comparable damage, yet only one might return to its own repair organization. The air battle, therefore, extended downward into geography and backward into industry. Range, rescue, salvage, transport, maintenance, and civilian labor influenced the meaning of a victory claim. This was the larger system hidden inside the wrecked fighter. Britain also drew strength from beyond Britain. Pilots from Poland, Czechoslovakia, Canada, New Zealand, Australia, South Africa, and other allied countries served in the defense. Their contribution cannot be reduced to an emergency footnote. Fighter Command's regeneration depended on aircraft, but aircraft required trained people to operate them. Here, the system's limits became stark. A repaired Hurricane could be inspected and returned to a squadron. A dead pilot could not be restored by any workshop. An exhausted controller, rigger, fitter, telephone operator, or rescue worker could not be replaced like a panel. By late August, the pressure on experienced fighter pilots and key southern units was more dangerous than aircraft totals alone suggested. This is why the repair story must not become a mechanical explanation for the entire British victory. Radar warning, the observer network, command and control, aircraft production, operational leadership, geography, and German decisions all mattered. So did the courage and losses of aircrew from across the Allied coalition. The civilian repair organization was one part of that defensive structure, but it attacked a crucial vulnerability. It reduced the rate at which combat damage became permanent material loss. That capability gave commanders choices. Aircraft could be moved between units. Damaged machines could leave the operational ledger without leaving the national inventory forever. Reserve aircraft could fill immediate gaps while workshops worked on slower returns. The system separated today's shortage from tomorrow's total. German intelligence largely saw the first number. British administration managed both. When the Luftwaffe shifted its main weight toward London in September, Fighter Command received relief from the concentrated pressure on some airfields. The change did not rescue an air force with only a handful of fighters remaining. That familiar image exaggerates how close material collapse had become. The RAF was strained, especially in pilots and within Number 11 Group, but it retained a functioning national system and hundreds of operational fighters. German estimates had repeatedly placed it much nearer extinction. The raids on London then exposed that miscalculation publicly. Large German formations expected to draw out and finish the remaining defenders. Instead, substantial British forces intercepted them. The encounters did not prove that Britain possessed limitless resources. They proved that the German model of British exhaustion had failed. Every fighter rising into those formations carried evidence of several systems working together. Some were fresh from factories, some came from reserves or other units. Some had already been damaged, recovered, and repaired. They looked identical from a bomber's gun position. That was precisely the point. The Luftwaffe could destroy machines. It could not reliably determine how much lasting strength each attack had removed for the workers inside the repair chain. Regeneration was not an abstract curve on a headquarters chart. It meant scorched fabric, distorted metal, leaking fluids, and airframes carrying evidence of the pilot's escape or death. Mechanics worked against the clock while raids continued. Recovery crews entered fields where wreckage remained unstable and unexploded weapons could still threaten them. Civilian workshops also operated under the possibility of bombing. Their success was measured by absence. An aircraft returned to service ceased to look extraordinary. It joined a squadron, received fuel and ammunition, and became another fighter waiting beside a dispersal hut. The repaired structure disappeared beneath paint. The salvaged instrument disappeared inside a cockpit. Only the serial number and maintenance records preserved the machine's complicated history. This invisibility helps explain why repair rarely dominates popular accounts of the Battle of Britain. Combat produced dramatic images and named aces. Factories produced impressive totals. Repair occupied the uncertain ground between them. It converted neither raw material into a new aircraft, nor an aerial victory into a celebrated story. It simply prevented recoverable capacity from being discarded. Yet wars of attrition are decided partly in that middle ground. The question is not only how many machines each side possesses at the beginning, it is how quickly each system converts damage into permanent loss. And how quickly it reverses that process. An air force that restores aircraft, rescues pilots, redistributes reserves, and repairs infrastructure can absorb blows differently. Its apparent strength after a battle may conceal enormous effort beneath the surface. German intelligence mistook that concealed effort for evidence that its previous calculations were almost complete. Again and again, continued, British resistance was treated as the expenditure of a final reserve. The expectation survived because it was difficult to abandon. Accepting a much larger RAF meant accepting errors in intelligence, combat claims, production estimates, or all three. It also meant accepting that the planned short campaign had become a contest of systems. Germany still inflicted severe damage. The bombing killed British aircrew, ground personnel, industrial workers, and civilians. Fighter Command could not defend every town or prevent every raid. Its victory did not make the suffering below irrelevant. Nor did Britain's defensive success erase the destruction later inflicted through Allied bombing. The repair network belongs in history as an explanation of endurance, not a claim of moral simplicity. After the immediate battle, the civilian repair organization continued expanding into a vast wartime enterprise. Its workshops handled many aircraft types and increasingly complex restoration work. Experience improved collection, allocation, specialist repair, and the reuse of components. Methods developed under emergency conditions became part of Britain's longer industrial war. The system also released aircraft manufacturers to concentrate more heavily on production. A factory designed to build new fighters did not need to absorb every damaged machine returning from service. Repair specialists could preserve existing strength while manufacturing added fresh capacity. Separate streams supported the same operational force. That division of labor became more important as the war widened. Aircraft operated across distant theaters under harsh conditions. Maintenance and salvage followed them wherever practical. The lesson was portable even when the exact British organization was not. Combat power depended upon the network behind the machine. A technically impressive aircraft without spares, trained labor, recovery equipment, and transport could decline rapidly. A damaged but supportable aircraft could return. The Battle of Britain, therefore, cannot be understood by subtracting victory claims from factory totals. Those numbers describe only parts of the cycle. Between production and destruction stood assessment, salvage, cannibalization, repair, inspection, storage, and redistribution. Each stage contained delays and failures together. They preserved enough machines to complicate every German estimate. The decisive German misreading was not that Britain suffered no damage. It was that visible damage translated predictably into irreversible weakness. Britain's repair network broke that assumption one airframe at a time. Return finally to the fighter beside the cratered runway. Its propeller is bent. One wheel has collapsed. The squadron has already removed it from today's available strength. From the air, it resembles another German victory. But a recovery crew is approaching. An inspector will decide what can be saved. A trailer will carry the machine into a network. The Luftwaffe cannot observe clearly. Workers may restore the fighter or divide its surviving parts among several others. Either outcome denies the enemy a simple subtraction. That was the hidden contest beneath Britain's summer sky. German pilots fought aircraft. German intelligence tried to count their disappearance. Britain built a system that made disappearance temporary whenever men, machinery, and time allowed. The wreck was never the hero by itself. The hero was the chain that refused to treat damage as destiny, and that chain helped Fighter Command remain far larger than the force Germany believed it had nearly destroyed. If this changed how you see the Battle of Britain, follow for more stories about the systems behind victory.